going to put separate fractions. Say, did you learn to do adding fractions like this in elementary school? Did you do them like this, 2/3 plus 5/8? Did you write them up and down like that? You didn't. Some of you wrote them across. And I liked that when I taught taught 7th grade, 8th grade, because you could look at these. What's the common denominator? 24. And then you would say, what form of 1? Because it all comes down to fractions. They taught you in elementary school, you know, that half of a candy bar was, you know, cut it in 2 pieces, was the same as a candy bar cut into 4 pieces and you took 2 of them, or cut into 8 pieces and you take 4 of them. So as long as you're multiplying it by 1, then you can actually have a fraction that's equal to it. You know, if I multiply this by 8/8, 16/24 is going to be equal to 2/3. If you multiply, I think you do it in elementary school. I hope you get it in middle school and high school. So we need common denominators. We get that first, but then we got to decide what we do with the numerators, like if we do it sideways. Take them one at a time. 6 and 5, we have to have a 30. Okay. Now, here's the easiest way with variables or binomials that have variables in them. It's the most you see because you're wanting to multiply to get to what you want. You know, like times 8/8 or times 3/3. So if I have 3 m's and 2 m's, it has to be the 3 m's. Because you can get from m3 to m3. You can't get from m3 to m squared, m cubed I should say, to m squared easily. And again, we'll talk about, because, you know, we're kind of working it as if these fractions wouldn't reduce. And so I have 1 n, I have no n, so there's got to be an n over here. You've got to be able to take each one of these denominators and multiply by something, and that something may just be 1, to get to your denominator over here. So I'm going to go up in the air, and I'm going to put a fraction bar. These have to be written as fractions because these are not equations. We'll talk about equations later on. So I look at this, and I'll look at this. What is this denominator missing from this one? 6m cubed to 30m cubed n. What can I multiply this by to get to this? 5. Okay, we'll put a 5/5. And if you're going to show it, you've got to show it as 1. Because if you only put 5 up there, you're only multiplying the numerator. You're not changing that denominator. You write it mathematically correct. And then what else is missing? An n. So 5n over 5n. You want to go ahead and multiply it? We got 20mn. Now, what's this one missing? By multiplication, not division. That's why we always go the same level or up. So 5 to 30 is a 6, times 6, over 6. And you've got 2 m's, but you need 3, so you need another m. And what about the n's? We've already got it, right? So we have 12m. I'm going to put them in alphabetical order, so I'll have 12mn. And we can add just like we did in lesson 19. And so we have, and you have to really be careful with like terms. 20mn and 12mn are like terms. So I have 32mn over 30m cubed n. Now what will reduce? Will 32 and 30 reduce? 2 goes into them, what, 16 and 15? What about your m's? They cancel? How many you left where? 2 on the bottom. And what about the n's? Okay. So, and the thing I wrote on here, I just said about the variables, and you're really finding the least common denominator. I mean, I could have used m to the 5th, see, because I got m to the 3rd, m to the 2nd, if you multiply those together, but I'm trying to do like I did with the 8 and the 6. I'm trying to say m times m times m, m times m. They have 2 m's alike, so I need 3 of them in my common denominator. So I put least common denominator of variable, and I'm terms, is the most, and again, that's not very mathematical, you see. Now, I'm going to draw an arrow from this to this, and I'm going to put a big or. And I think we might want to start doing this if it will work. because I think it makes it a little bit easier. Let's take the original problem, 4m over 6m cubed plus 2n over 5m squared n. Now this really works on ones that are monomials like this. I don't know that it's going to work with parentheses. We'll just have to see. What if we reduced them before we added them? Let's see how much easier it would make it. Well, I can reduce the 4. I mean, like I said, you know, if they had common denominators, I'm not going to do anything to them. But if they don't, it really doesn't matter. So 4/6 could become 2/3. And now this is kind of messy, but the m, maybe we need to do it here. 2 and 3. And then if I have 1 here and 3 here, I'll have 2 left on the bottom. See, I'm just reducing them. And then what about this one? I have 2 and 5, won't reduce. My m's don't reduce, and my n's are gone. Now, how much easier is that to get a common denominator? It's a little bit easier, isn't it? I already got the m squareds. I don't have to worry about them. This one, the LCM, the LCD of 3 and 5 is 15. So all I got to do is multiply by 5 over 5. And this one by 3 over 3, and we get 10 over 15m squared plus 6 over 15m squared. And look, we actually did the reducing in the problem. So if you can reduce, especially with these, I call these monomial terms, you know, it's already multiplication, and you can just start canceling. We'll see what we can do. I don't think this second one's going to. Number 2. 3 over m plus 5 plus 6 over 5. Now, I did this one on purpose because many people think that 5 is the same as that 5. Remember, that's actually 1 times m plus 5. So you need to factor the denominators if possible. Because that's where people get, and I'll put if possible, because people get these humongous common denominators. They're not the least one, but you definitely want to factor denominators. So I'm going to go ahead and write that. Okay, now watch carefully. Let's do the same thing we just did. Okay. The numbers, the coefficients are 1 and 5. What's the LCD of 1 and 5? 5. So it got to be a 5 over here. Okay. Now treat this m plus 5 just like the m, the n, treat it as a variable term, and I have one of them. See, it's raised to the 1 power. I don't have one over here. The common denominator is the most you see, and I see one of them, m plus 5. And if you want to put the 1 on it, m plus 5. So what's missing from this one? On the bottom, what's the difference in 1 times m plus 5 and 5 times m plus 5? What do we need to multiply by? 5 over 5. So I get 15. Now, don't come back over here and cancel. We talked about that on lesson 19. Because if you cancel now, you won't have common denominators anymore. You know, once you get common denominators, you add and then reduce. What's this one missing? Plus 5 over m plus 5. Now, the bottom we left factored. We need to do that. The top, you go ahead and distribute. Because, dear Aunt Sally knows that if we're going to add terms, we have to have no parentheses. So we're going to go ahead and say 6m plus, I don't know if I wrote it that way last year or not. Yeah, I went on and distributed it. Go ahead and distribute. And now it looks like, if you've done 19, it looks like 19. Okay, can we put anything together on top? No m's over here. I have 6 m's over here. I'm going to put the m's at the front because that's the way it is on the bottom. 15 plus 30 is 45. And we're going to leave the denominator factored. Leave denominator factored. Because you know what we're fixing to do? We're going to factor the top. So I think I actually did try to give you some that most of them are going to factor. What about on the top? Now, just because they factor, nothing may cancel. I think that may be what's fixing to happen. I don't know. The GCF of 6m. I tell you what, we'll do it here, but a lot of times I do it above it just to see if anything's gonna cancel. If it doesn't cancel, I just leave it. So I think the GCF here is 3, and I have 2m plus 9 plus 15 over 5 times m plus 5. Okay, it did factor, but 3 and 5 don't cancel. 2m plus 15 and m plus 5 don't cancel. You can actually do either one of these. I'll just circle. You can leave it without parentheses. You can factor it to see if it would cancel. I usually just stop at this one if I see, because a lot of times I'll just write it above it. I'll go, okay, take a 3 out. I'll get 2m plus 15. That's not going to cancel, so I just leave it.